Okay, so let's look at the graphic organizer that you have at the front of your notes. You already took some time to write in the area formulas, and let's make sure that you found the correct ones. Go ahead and hit pause and look over the formulas that you have to make sure that they're written correctly. When you're finished, come back. Okay, so there's the area of the triangle. There's the area of the circle, pi r squared. Remember, the area is always squared. And the circumference is the one that's not squared, 2 pi r. The rectangle can have more than one formula. You might see length times width some places. The square has at least one other formula that you could have written as well, but these are the most common ones. For the trapezoid, base sum means you add the two bases together, multiply by the height, then divide by 2. Okay, so now that you know the area of all the shapes, let's look at the properties. In class, if you had time to find all the properties, then go through this video quickly and just check to make sure you didn't miss any. But if you didn't have time in class to find all the properties, then go through this slowly and make sure you get them all written down. We're going to start with the triangle, then the circle, then we'll look at the quadrilateral family. So for the triangle, you already know that the area is base times height divided by 2. But what makes a triangle special? It has 3 sides. Nothing else has 3 sides, only triangles. And then it also has 3 angles, 3 sides and 3 angles. Another thing that's special about the triangles is that the angle sum, if you add up this angle, and this angle, if you added up x, y, and z, you would get 180 degrees. That only happens in a triangle for the angles. For circles, you already know the area formula and the circumference formula, but for the properties, what makes a circle special is that it has no sides. It's all curves. Or if you look at the degrees of a circle, you will always get 360. And also all the radii are equal. Radii is just plural for radius. You start with the center and you go to the edge. That's a radius. But this radius is equal to this radius, which is equal to this radius, and any other radius that you could see. Those are the main properties of a circle. There are many types of quadrilaterals, but there are some things that are common to all quadrilaterals, and let's look at those. First of all, quadrilaterals, no matter what they look like, all quadrilaterals have 4 sides and 4 angles. 4 sides, 1, 2, 3, 4, and 4 different angles, x, y, z, and a. Those are the 4 angles right there. What's special about a quadrilateral also is that the angle sum is 360 degrees. So if you added this angle, this angle, this angle, and this angle, altogether you would get 360. Now within the quadrilateral family, there are some special groups, like the parallelogram family. Think about what makes a parallelogram look the way that it looks. For one thing, opposite sides are parallel. That's where it gets the name, parallelogram. So when you look at a parallelogram, the opposite sides are always going to be parallel to each other. And the symbol for parallel is matching arrows like this, and then this side is parallel to this side. These two sides will never touch, neither will these two. Another thing is that opposite sides are congruent. This side is congruent to this side, and this side is congruent to this side. That means they have the same length when you go across. Opposite angles are congruent. So whatever this angle equals, this angle is also going to equal the same thing. And this angle is going to equal this angle. Another thing is that same side angles will be supplementary. If you look at 2 angles side by side, they will always add up to 180. Same for these two, same for these two. And lastly is that the diagonals will always bisect each other. That means that when the diagonals cross, they cut each other in half to equal parts. So this piece right here is equal to this piece. This half equals this half. And this half equals this half. This piece equals this piece. So all those things are true for a parallelogram, but since parallelogram is in the quadrilateral family, you also know that there are 4 sides, and you also know that all 4 angles add up to 360 degrees. Within the parallelogram family, you have 2 parts. You have the rhombus and you have the rectangle. What makes the rhombus special is that it has 4 sides that are congruent. Yes, all the other parallelogram properties apply. The opposite sides are congruent, opposite angles are congruent. Everything you know about a parallelogram is true for a rhombus. But there's two more specific things. 4 sides are congruent. This side is congruent to this side, and this side, and this side. All 4 are equal. But in a rhombus, what's special is that the diagonals are perpendicular to each other. Okay, so yes, it's true that the diagonals are still bisected. You could still cut them equally in half. But specific to a rhombus is that when the diagonals meet, they form a right angle. So what you really have here are 4 right triangles within a rhombus. Okay, there's also the rectangle. The rectangle is within the parallelogram family, but it's not part of the rhombus family. A rectangle has all of the properties of a parallelogram. Opposite sides are equal, opposite angles are equal, diagonals bisect each other, but there's 2 more things that are particular about a rectangle. First of all, it has 4 right angles. That's what makes a rectangle a rectangle. And all of the 4 of them being 90, 90 plus 90 plus 90 plus 90, it still adds up to 360 degrees. What else is special about a rectangle is that when you do look at the diagonals, they're not perpendicular to each other, but they are equal to each other. This whole entire diagonal would equal this whole entire diagonal. They're still cut in half. This half would equal this half, but it would also equal this half and this half. The square. The square is special because it's a rhombus and it's a rectangle all put together. So the square has all the properties of the parallelogram that you see up above, all the properties of the rhombus that you see up above, and all the properties of a rectangle. So it has all 4 sides equal, just like a rhombus. It has all 4 angles equal, just like a rectangle. It has the diagonals are equal, but the diagonals are also perpendicular to each other. Everything that's true for a parallelogram, a rhombus, or a rectangle is also true for a square. All right, on the right-hand side of your organizer, you're going to see the kite. The kite is just like what you think about, the kind of kite that you would fly in the sky, but it is not a parallelogram. A kite is separate from all the parallelograms. What makes a kite is that there are 2 pairs of congruent consecutive sides. Consecutive sides are sides that are next to each other. So this side can equal this side, not the side across from it. And this side can equal this side. So opposite sides are not equal, not a parallelogram. Secondly, the diagonals are perpendicular. So just like in a rhombus, the diagonals are perpendicular to each other, but they don't bisect each other. You can tell that this piece is not equal to this piece, but they do make right angles. So you have 2 congruent triangles here and 2 congruent triangles here. Only one of the diagonals is bisected. Only this half is equal to this half. These 2 halves are not equal. And then a whole third category is the trapezoid. It's not a parallelogram and it's not a kite. A trapezoid is special because it has 2 sides that are parallel. Only 2 sides are parallel. So this side, it doesn't have to be the top and the bottom, but it's any 2 sides that are parallel to each other. There's a base, and here's another base. So these 2 sides are not. In an isosceles trapezoid, 2 sides have to be equal. Can't be the bases, so it has to be the 2 legs. This leg is equal to this leg. That's what makes an isosceles trapezoid different than a regular trapezoid. Now, in addition to that, you also have base angles are congruent. So this angle along this base is equal to the angle along this base. Those are congruent marks to show that they match each other. And this angle across the top base is equal to this angle across the top base, which shows that they're equal to each other. And lastly, another thing about trapezoids or isosceles trapezoids is that the diagonals are congruent. They don't cut each other in half, but they are congruent to each other. This piece equals this piece.